welcome everybody to the webinar. Good morning to the US, a good day to Europe, and a good afternoon or good night in Asia. Darshan and myself are going to have a presentation on traceability in complex simulation processes. What we actually want to do in this demonstration is I will give you a short introduction just for everybody very fast around what is SimManager. Then I will introduce the demonstration use cases and then actually run the demonstration and complete with a conclusion. First of all, on SimManager, what is SimManager? SimManager is a data and process management system which really focuses on industrial needs of customers which have many products and derivatives, many duty cycle load cases, multi-stage and multidisciplinary simulations, and they want to have a systematic, consistent data and process environment for their whole CAE processes to manage the data, to address then also requirements from regulatory environments and liability, and run optimization and performance. And really what we are also noticing with our key customers is that they have challenges in really filling the headcounts, the engineering staff, so they really need to make sure that they build for their engineers an efficient environment which allows them to have maximum effectivity and efficiency in their day-to-day work. Okay, so the sweet spots around SimManager is, as I said, a data and process management system is really to trace and audit the whole data process, and this is something which will be our topic today, and really along that traceability, manage all the artifacts, all the data which was generated in the simulation process, and this is what we're also going to show, drive the simulation process from the system itself. And of course, ultimately, such an environment should then be integrated into the bigger PLM environment. And this is something which we're not going to focus on today. We had other webinars where we discussed this topic in detail. So just from the key aspects, what are the key elements of SimManager? So the key components of SimManager is, first of all, the data management aspects. So really the ability to manage, and it's designed really to manage large and heterogeneous data sets. What we are encountering in the simulation process, you have small files, you have big files, you have huge and very huge files. You always need to import and export not just one file, but always a whole set of data, a directory structure in and out of the system. So we have configurable import-export mechanisms. And then once the data is in, you want to, of course, be able to efficiently search for data and also provide a consistent security and access control policy. And of course, with almost every engineering company, you need to operate on a global market, in a globally distributed organization. Okay, that's the data management aspects. The process management aspects are really to manage and govern the simulation process. The concept of SimManager is, and this is hopefully something we can show you today, is not that you do the simulation outside of the system and then check in the data manually. Our experience in such an approach is that typically the data checked in such systems is very selective, and at the end you don't have really all the data in the system which was generated in the simulation process. So our concept right here is that you actually run the process in the system, and just by default all the data you generate is immediately in the system. Actually, the engineer does not decide what he imports into the system. The engineer decides what he deletes out of the system. So it's a little bit of a reverse process, but it has very many benefits of running the process through the system by driving it through the system. Particularly if somebody, is out sick, you have full confidence that all the data that he has worked on is in the system and organized. Part of that integration is also an efficient HPC integration. Darshan will point out some aspects of how we do it, particularly in terms of what we will explain to you multi-run. And then we have around that capabilities of simulation generation and report generations. Today we will focus mainly or exclusively on a simulation generator in the demonstration. And clearly, if you have a web-based environment, you can support very easily and very effectively collaborations between your co-workers at different locations. And what we have in the system, and we had a webinar on that, is around the concept of work requests, so that you can issue work orders, etc., in the system and structure work, and then have that be dispatched to the users, and then also share the data. What we're going to do today is we're not going to focus on that part, because that would kind of like just be too big of a demonstration. So this collaboration aspect is currently not the focus in today's seminar. Something I do want to mention right here, and this is kind of like my segue into the whole traceability discussion, is key aspect of SimManager is, as you run the process, is really to manage the data as it is generated, starting from the CAD model, going over the input decks to the result files. And then we trace the dependency graph. Now, in a simple simulation, you have models, input decks, results. What we're going to do today is really go into a more complex process, which we call the chained simulation process. So just to outline that process, what we are going to demonstrate in the demonstration today is a process where you, for instance, have a thermal department which takes a structure and does thermal simulation, calculates heat distributions on the model. Now, once that organization has generated this department has generated those thermal distributions, actually these models are passed to the structure department, and the structure department runs then structural simulations, taking as input the output of the thermal models of the thermal department. You have quite some challenges in having such two departments working together, handing over data between those departments, and we're going to show you how this will be operated and how the data looks in such a scenario in SimManager. We're going to show you the importance of traceability and tracking, because you have a structural model, you have a thermal input deck, you have different models, you need to know based on which design states they are, etc. So you need to really be tracking and tracing exactly from where the data comes from. Now, to add to this chain simulation, typically in this specific use case we are explaining to you today, showing to you today, you are actually creating you're running multiple thermal simulations for different situations, creating different thermal fields on your model. And so you're not just passing over between the thermal department and the structure department one thermal model, but a series of thermal models. And then in the structure department, you need to take all those series of thermal models and run them and do multiple simulations, like right here in our example with solution 400. This adds another dimension to the whole bookkeeping of the data as they're passed over between departments, and just being clear, did I do simulations with all the thermal models? Which thermal models did I use for which simulation, which structure model you have? So you have very much of data management questions a system like SimManager should answer to you, to make you feel comfortable as analyst that you have used the right set of models, that you have done the right set of simulations, and that you have analyzed and generated the right result sets going forward at the end. And this is today's motivation and today's demonstration, where we're going to show how this is realized in SimManager. So what you're going to see in the first demonstration from Darshan is you will see this audit trail, which just now includes a thermal model and a Nastran result of a structural part. So you have thermal outputs, you have structural outputs, you're chaining them together, you have many thermal models, you have many Nastran results, and how you need to navigate in the data, how you can organize the data, how you can visualize the data is going to be the first demonstration by Darshan Joshi. With that, I hand over to Darshan. Darshan?
Okay, thanks. Good morning and good afternoon, everybody. Before we go into the demonstration, let me give you a little bit of overview of the analysis that we are referring to here. It's a chained thermal structural analysis of a satellite model that you see here on the screen. The heat load or heat source here is the electronic circuit, which are used for navigation, propulsion, and space experimentation, etc., in the lifetime of a satellite. These circuits are placed at the ends of this cylinder that is at the core of the satellite, and then the cylinder or the core of the satellite is connected with the fins and the top and bottom sections of the satellite. The heat is conducted to the peripheral parts of the satellite, and there is also radiation to the outer space from the peripheral parts of the satellite, which is modeled by the NASA ambient space option. What you see here on the right hand side of the screen is the temperature distribution arising out of the thermal analysis, and what you see here on the left hand side is the corresponding stress distribution because of the heat profile or the temperature profile generated. So the demo is structured into two parts. Part number one, we will focus on data navigation in the system. So let's assume that a thermal analyst and a structural analyst from different departments, probably in the same organization, working together, have conducted this analysis using SimManager as Simulation Lifecycle Management System. And me as an analyst, I'm going to log on to this system and navigate through the data that is available in the system to trace the dependencies and relationships in this simulation. So first thing you do with SimManager is you log on to SimManager because it's a web-based system. Once an analyst logs onto the system, he sees his homepage. All the data that is frequently accessed by analysts like input decks, models, results, commonly used actions, and executable projects is shown to the analyst on the homepage. The data to which the analyst does not have access does not appear or is not shown to the analyst by default. So let's say, for example, the thermal analyst has already run 10 different thermal simulations into this project, which is a thermal simulation project. In this context, it could be varying the heat flux because of various different environmental factors or various different heat loads generated by the circuits. And then he has created 10 different thermal simulations. These 10 thermal simulations are released by the thermal analyst or the thermal department to the structural department for further structural analysis. And the structural analyst has performed the structural analysis into a different project, which is for structural analysis. Let's say this is that project. When I go into this project, I see that there are 10 input decks into this system, which correspond to each of the thermal analysis. And then there is another input deck here, which is master input deck, which aggregates all these 10 input decks. So when I go to the SOD or the single object display or the detailed view of the structure's master input deck, what I see here is a snapshot of the entire simulation. So I see here all the individual structural runs, all the individual NASA simulations listed. I see all the processes corresponding to these simulations listed here. I see URLs to each and every individual simulate process. If I click on that, I go to the detailed view of the process. That will tell me how this simulation was run, which NASA solver version was used, which post processor, which cluster interfaces were employed, so on and so forth. All the data that you see here is dynamic. So as this simulation is happening, the data starts appearing in. The next tab I have on the SOD of the structure's master input deck is components. These are the components that were assembled to create the structure's master input deck. What you see here is a master thermal model which aggregates all the individual simulations of thermal department. So 10 different thermal simulations are aggregated here under this master thermal model. And you see there is a structural model and a structural LBC. LBC is the loads and boundary conditions model, and structural model is actually the structure's mesh. You could also imagine here that although I have a monolithic structures mesh here, I could split my satellite model into the core, cylinder, and the fins, and the top section, bottom section, etc., etc. So there could be more components to this particular assembly. To keep things simple, I currently have the 3 components listed here. Next tab I see on this is key outputs comparison. This gives me a snapshot of all the different results or all the different outputs that me as an analyst I'm interested to know from this simulation. So the first section I have is maximum stress comparison. In this section, what I have is table number 1, which gives me values in a table format. So the maximum stress values for individual simulations. Table number 2, which gives me the image comparison of all the different simulations. So for example, if I'm interested to look into the details of this fringe plot, I could click onto this fringe plot and go into the details. I also have the same comparison here on bar charts for maximum stress. Followed by the maximum stress section, what I have is the maximum displacement comparison section, which again lists the values of the maximum displacement in tabular format, in image format, and also finally in the bar graph format. SimManager data pedigree feature gives me entire snapshot of the simulation from the data perspective, from the relationship perspective. So for example, if I do the data pedigree on the structure's master input deck, it immediately shows me on the left-hand side what were the components that were used to assemble this master's input deck, what were the dependencies of these components. So it gives me access to the thermal models associated, and it gives me access to the Nastan result and Nastan input deck associated from the thermal area on the left-hand side. Whereas on the right-hand side, it gives me a list of all the 10 structural input decks which were generated out of this master input deck. And then after solving those 10 structural input decks, I got 10 Nastan results, which are also mentioned here. I also see all the key results listed here. So for example, if I am to click on the key result images, I will immediately have access to all the different key result images here. These are all hyperlinks, so I could click on any of these hyperlinks and get into the details of that particular analysis. Let's do that for one of the structures input deck. Let's say I'm interested in looking into more details of this particular analysis. So what I see here is a detailed view of a structure's input deck. And on this detailed view, I also have a lightweight embedded viewer shown to me. And I also see that the SimManager system automatically extracted some metadata from the input deck, number of nodes, number of elements, number of load cases, parts, etc., etc. On this detailed view, I have a relation to the result that was generated from solving this particular analysis. If I go to the detailed view of the Nastan structural result, what I see here is the stress plot on the left-hand side and the corresponding thermal simulation results on the right-hand side. At this point in my web page, I can use this functionality of the lightweight embedded viewer to do a lot of fringe plotting for various different results that are of my interest. Similarly, I could do the fringe plotting right here on the thermal analysis. So for example, if I am interested in looking at temperature gradient or let's say heat flux variations and so on and so forth, I can do that right here. So getting back, let's say to the...
Darshan, may I have a comment?
Yes, please.
So just for everybody, we are showing this example with the thermal model, but kind of what we are doing, and this is one concept of SimManager, is really, you see right here that we have a very specific layout of the data, which is very specific and very optimized to this one process. So SimManager is a very easily configurable system. So really, what we are trying to demonstrate right here is that as you build complex processes, you can really tailor your visualization of the data towards kind of like showing all the aggregated data, all the data in a very concise, for you most efficient form. And right here we have, for instance, taken the viewer and displayed side by side the thermal and the structural. This means in other situations, if you want to visualize complex data, you can build easily in SimManager other display modes combining a 3D viewer with table, with bar charts, or with curves to really have a very effective dashboard of your information immediately ready, available, without having to always set up everything once individually.
Thanks a lot, Michael. So continuing on from that point, let's take a look at, for example, let's go back to the data pedigree that we started with. What I would like to point out here is, first of all, you see the entire data pedigree of this master thermal input deck in this one shot. It gives you a snapshot of entire simulation. At the same time, if I go to, for example, one of the individual shots or individual input decks and do the pedigree on that, what I can clearly see is the dependencies of this particular shot, of this particular structural input deck. It shows me that it depends on a structure's master input deck, which is the aggregate holding all the common, let's say, mesh and the LBC information in a model. And then it depends particularly on this particular thermal model. So this thermal model was used in the analysis of this structure's input deck. It doesn't take me even a couple of minutes to trace the dependent thermal simulation right away. Let me go to the detailed view of the thermal model, which is the aggregate of the, let's say, the master and deball files in case of Nastran. But something to note here is it's not holding the deball and master files, which could be really big in size. And in case of these complex simulations, you not only want to manage the relationships and pedigree information, but also want to make sure that your data transfer is as minimum as possible to increase the speed of the simulations. What you notice here is SimManager has a functionality to store the relevant information in terms of links. So for example, here I have a file which holds the path to the master file on your cluster. And when SimManager runs the dependent structural simulation, what it does is, let me open the structural simulation working directory. It creates a working directory for the structural simulation, and then based upon the information that was there on the corresponding master file, it creates the soft links in your operating system to the results, the deball and master files of the thermal simulation. And this avoids a lot of copying over at two places. One, between different computers inside your cluster, and also these files never go to your SimManager vault. So that saves a lot of throughput time as well. So in short, in this demonstration, what we saw is in this demonstration, what we saw is an ability in SimManager to manage the data pedigree, to maintain the relationship graph, and also to reduce the throughput, reduce the data upload and overall, let's say, volume of data that flows through such complex simulations. We saw how you navigate through the data, but I think a logical question at this point in time would be, How did I set up these simulations? What do I need to do to set up these simulations? How was it submitted? We will take a look at that part into the second part of the demonstration. At this point in time, I would like to hand it over back to Michael.
Thank you very much. So what I'm now going to explain to you before two slides just to motivate what Darshan is going to show in terms of the process execution. So what you've seen is just navigating in the data. What I've done right here is I've listed out really all the elements that Darshan has shown in his in the navigation in the data, and will now walk you through actually the process of the second part of the demonstration, so that you understand what Darshan will be doing by executing the process. What happens is as you saw, is we have a set of thermal models. And what happens is one process you need to have is, and this either is done by the thermal department or by the structural department, somebody needs to say, this is the formal set upon which I need to then perform all my structural analysis. So we create a master thermal model, which is a grouper of all the thermal models which need to be assessed. Then we go with this master thermal model into what we call the simulation generator. You see a picture down below right here, a screenshot, together with the LBC model and a structural model, and then launch the actual structural simulation process. What this does is it generates an input deck, a master input deck, which holds all the information of the whole assessment. And then in SimManager, we start a process which loops over all the thermal models in a consistent way, generates the individual input decks, and then runs those simulations. So the main point we want to show right here is you set up the master thermal model, and then actually it's a very few mouse clicks you need to do to then run the whole series and the whole slew of simulations for each individual thermal model, which is what we call in our nomenclature in SimManager a multi-run scenario. With this just short explanation, Darshan, I will hand back to you, and you will go through the process of generating the master thermal model, and then really launching the simulation generator, which then shows how the things are then submitted back into the HPC environment. Darshan?
Let's take a look into the second part of the demonstration. As Michael explained, how is this multi-run feature set up in SimManager? Let's say I want to run another set of thermal structural simulation based upon the same thermal simulation that was done by my colleague from the thermal department. I have a different project set up for this new set of structural simulation. When I go into this project, I see that there are some objects already created in the system. These are the objects that are necessary to set up a feature of SimManager called Simulation Generator. Simulation Generator is a feature of SimManager which allows you to templatize your assembly and simulation processes. It allows you to pre-decide what are the components of your simulation and how are those simulations going to be run. That is, which solvers are going to be used, which post-processors are going to be used, and are you going to run a series of simulations or is it a single simulation, so on and so forth. So when I go into here, I see that there are some variants already set up in the system. Now, this setup is done for me by a methods expert in my organization. So I am pretty sure that me as a novice engineer, I'm going to follow a process which is the same organization-wide, irrespective of which country I am based out of or which location which department I belong to. So what I see here is the components of the simulation that we saw in demo 1. There's a master thermal model, there's a satellite assembly, which is the overall umbrella, and there's a structural mesh, and there is an LBC. At this point in time, let's say my methods expert, my senior colleague, has already defined some of the other components like the mesh and the boundary conditions, and my responsibility is now to refer to the corresponding thermal simulations and submit the simulation. So I go to a variant that corresponds to the thermal model, and I create a master thermal model. format here is Nastran, could be anything, but since we are using Nastran as a solver here. Then I go to the Generated From tab, and I select the thermal models, the individual thermal runs, which I want to refer in my structural simulation. So some of the UI capabilities, for example, I can filter by the type, and I see that there are these 10 thermal simulations available in this thermal project called Thermal Simulation 1. Let's say, for the purpose of simplicity, I'm interested in only referring to 3 of those thermal shots. And then I say OK. At this point in time, my master thermal model is ready. What I will do now is I will go to the variant that corresponds to the satellite assembly, which is the parent or root node, and I invoke a feature called Simulation Generator from here. What I see is that the 3 components that I'm interested in assembling together and then running the multi-run simulation downstream are listed here. At this point in time, I'm going to go ahead and hit submit, which will create a multi-run process for me. But I do want to point out here that there is also a possibility that you can vary your structure. You want to do some changes in your mesh. So for example, if I click on this drop down, I see that there is already a newer version of the mesh available. I could select that and I could submit the simulation, or if I want to continue my study from my previous simulation, I could stay on the same variant. I hit submit on this screen, and this submits the analysis. At this point in time, SimManager will give me an option to preview my analysis and make any changes if necessary. It will show me what assembler setup it is going to run, what solver setup it is going to run, and how it is going to post-process. If I want to change something, I can do so. Currently, I'm happy with the suggestions given by SimManager, so I say submit. And on this window, I see that a multi-run sim process is created. So this sim process is a sequence of actions, sequence of steps. As step number 1, it is going to assemble those 3 components that we saw, and it is going to create a master's structure input deck, master structures input deck, which we saw in the previous demonstration. And in the next step, it is going to create the individual shots, that is the individual input deck. That step is also now complete. So I now see that the structures, individual structures input decks are created. And in the next step, what SimManager is going to do is it is going to spin off simulate processes corresponding to each of those input decks. So you see 3 simulate processes running here. Now these processes are spawned on your cluster. So based upon how powerful your HPC cluster is, this could finish within 10 minutes, or it could go on for let's say 4 hours or 5 hours. And after everything is finished, SimManager will fetch back the results and show it to you in a Pedigree format, just like we saw in the previous demonstration. So let's not wait for all the processes to complete, because we have already seen the downstream data navigation. At this point in time, we come to the end of the second demonstration, and I would like to hand it over back to Michael.
What we wanted to have shown to you today is we wanted to have shown to you an explicit implementation of a complex simulation, managing all the data artifacts within the simulation, and also managing all the artifacts, and also managing all the artifacts created in those simulations, showing you that we can customize based on the process how the data is presented in an effective way. So we have tailored in very easy configuration the system for the specific process, and that can be done by you for your respective complicated simulation process. In the second part of the demonstration, what we've shown you is actually how simple you can actually issue the simulation process. What I do want to point out right here is we have demonstrated exclusively product capabilities. So there is no, in SimManager, no requirement to run something like that for you to codify any kind of complex processes in the system. This is all by using the generic SimManager framework and the simulation generator, and then just linking in your specific scripts doing the CAE methods. Everything else, running the simulation, organizing the data, running the post-processor, all that aspect is actually handled through out-of-the-box capabilities. This allows you to do such a simulation. Setting this up should be a very straightforward task in your organization to manage such processes, even if multiple departments are involved right here. So with this, I basically want to close off and hopefully I could motivate that we can manage the data and the process, and particularly based on our experience with customers using particularly multi-run, we see at many customers a huge growth of data volume and a huge acceleration of their throughput capabilities of running much more systematically than before their simulation process, generating much more shots and much more data, which makes their predictive, their predictions and their outcome for the design process much more reliable and thorough. With that, I want to close and ask you to, if you have any questions, we're happy to answer